Hi, how you doing? My name's Champ Clark. I work with a company called Key9. A few years ago, I used to work at a company called Quadrant Information Security, where I was a CTO and one of the founders. And what's kind of cool is I've met several people in this room who have passed through there or work closely with or whatnot. And it's always been a great experience just to see people again. Just to give you a little background, I come from a old school Unix days where my main operating systems were these operating systems called like Ultrix and SunOS and cool stuff like that. And I really wanted an operating system like a Linux or a Unix-like operating system that I could run on my 386 at home. Because it was a 386 40 megahertz with like 4 mega RAM. And I was just like, I had a friend who had an Amiga and it did all this great multitasking. And that's where I found Linux. And the distribution at that time that I chose was a distribution called SLS, which later became Slackware. It's old. This is pre-1.0 days of the kernel and stuff like that. And it was wonderful, by the way. And now you don't really have SunOS and stuff like that. I've actually started another project that I'm doing in my spare time to load antique operating systems and virtualization and see how many I can get running on one server. Just because, no particular good reason. But I'm not talking about any of that today. Today I'm talking about centralized configuration as a service. And we wrote a small utility that helps us with our configuration, and we use it in a lot of different ways. As I said, I work at Key9. We started out mostly doing passwordless identity, things like passkeys and stuff like that, which I'm still heavily into. So we built an identity platform that is based off of passkeys. Passkeys are just another fancy way of saying public key cryptography. It's a really, really kind of cool thing. You're probably seeing them, probably using them. A lot of people use them, don't even know that they're using them. They up and say, hey, do you want to try this new method of logging in where it's a lot easier? And with that, they'll set you up with a passkey. We also do getting more and more into SOC orchestration with AI and stuff like that, which is a lot of fun, which kind of led into this particular project, which I'll go into a little bit more later. So we built JSONair as a some problems that we and these are problems that other people. And we only use MIT just because that allowed any take it, modify it, put it in a thing, install it on your devices, don't really care. We'd really like to see some contributions if you do use it, and in the way of like, helping out with the project somehow. It could be documentation or adding new features to it or whatnot. So feel free to fork it, use it however you want. There's no strings attached. Down at the bottom here are the URLs to the documentation and to the GitHub repo, okay? Also, a few other things that I'm involved with. I'm working on another project right now. I wanted to give the talk about, that project is called High Volt, and it's where we're using open weight models to identify documents within networks. This has been all done before. The problem is companies charge a lot for this, and then you have to send all your data to these third-party companies. And I didn't think that worked very well for a lot of organizations because maybe you have medical records and things like that. So we developed a piece of software that we're open sourcing called High Volt, which allow you to identify documents while they're in transit on the wire or from other things. And I'm giving a talk in Lisbon, Portugal in November about that, which I'm really, really excited about that. Another organization that I've been involved with is the Code Alliance. They're a startup incubator here in Jacksonville, Florida. And if you get a chance, they're a lot of fun. They're always looking for like engineers. They're looking for people who are doing startups. They're a loose-knit kind of guy. They kind of have a hacker space. It's like this big garage full of fun tools and stuff to play with. And as a matter of fact, on May 30th, between 6 and 9, they're having a get-together. So if you're a Linux nerd like me, you can show up and hang out with other people like you, or if you're doing a startup or something like that, or want to bounce ideas off people, it's a lot of fun. It's a good place just to kind of hang out. And they're doing like free food, and it can go on very late. This year it starts a Saturday at 6 p.m., ends at 9. I think the last one, they said some of the people didn't leave till like 3 a.m. Because when you get geeking out, you don't want to stop. So they do that. So kind of people after my own heart. So I want to give them a shout out. So here goes a really quick thing about what we're going to cover with JSONair. Some of the problems that we saw with configuration management, there are lots of solutions out there. What we saw problems with them. Core philosophy, architecture design. We're going to kind of nerd out a little bit. I always call this software, it comes with batteries. So we give you not just the server side, but we give you an agent as well so that you can actually see like how the software works rather than trying to figure it out. And basically, I'm just going to run through how things are set up and why we chose these particular ways that we did it. Obviously, we primarily run the software on Linux backends, but you could in theory run it on FreeBSD, Windows. I don't know why I do that, but other stuff like that. So the problem with flat files that we have, as probably everybody here knows, whether it be your YAML and maybe you have some JSON blob that acts as a configuration file, and they all require some sort of manual management. So if you're dealing with like containers or whatnot, you have to push those YAML files into your containers, which means like whenever you want to change something, you may have to redeploy it and rebuild your container and redeploy it or whatnot. And that can lead to like a lot of different problems. There's several ways to do it. It's just none of them are very good. So you'll notice as the industry, as more and more stuff gets more cloud-based, we're kind of moving away from like the traditional YAML files in a lot of situations. Not all. There's a lot of software that still uses it, but so that we can move on to something that's a little bit more broad spectrum. Also, if you have a YAML file and you're trying to push it out to 300 nodes, it gets very cumbersome. You have like these shell scripts that are SCPing files around, restarting processes. It can be kind of a pain in the butt. So change management just becomes, change management becomes kind of a full-time job in that. So then cloud computing comes along and everybody says, well, we'll just use good old-fashioned environment variables or .env files, right? And that actually works a good bit better. But you still kind of have some of the same problems that you have to somehow get these environment variables into the containers themselves. So they either have to restart the containers for them to take effect, or at least at the very minimum, restart the software, somehow get the environment variables in there so that it can be done. There's also other issues with it. Like as you're in mid rollout, you'll have half your cluster running one version and half this. There's a little bit of, that can take a while. And if your upgrade for 300 nodes takes 30 minutes to transfer out the files, or 20 minutes, or 15, it means you're gonna have a lot of nodes out of sync for a little while. Plus, there's no versioning, there's no history. Managing secrets and environment variables can be kind of weird. You have like AWS perimeter store, things like that. And then you end up like with this glue that kind of works. It kind of works. So then vendors came out. AWS, Azure, all those guys come out and they say, hey, well, we have an idea. Why don't you just use our secrets vault? Or why don't you use our, if you're loading a Lambda function, why don't you just load your environment variables in here? And that's fine, and it works pretty well, but now you're tying your code directly to backends that you may want to move one day. You may not picture it right now, but you may look at it and say, well, we're always going to be in AWS. Well, that works out great until Google comes out with some feature that you really want and you decide that you move, or management tells you. We're no longer using it for cost reasons. We want to move from GCP to AWS. We've actually seen that happen before. So then now you're having to go through and recode things, which is kind of ridiculous when you're dealing with configuration files. Now, it really kind of couples your code to the cloud that you're in. Also, too, the other thing I don't like about it is that you don't own your infrastructure anymore, which we're kind of going to. Kind of sucks, in my opinion. But there are some things that we can still kind of control, and this is one of those things that we can control, is the infrastructure and data pipeline. So JSONair for us is cloud agnostic, doesn't really care about where you're hosting it. It could be on Iron, VMs, whatever. But there are alternatives. So like HashiCorp has their Vault, which is super powerful, but the APIs are more complex than we found them used to. There's like a bunch of different solutions. I didn't go through them all. But every time that we went through, it was just kind of heavily, like they have different ACLs and all these different things. And I'm like, I just want something that just works, that I can just stand up and preferably not have a whole ton of complexity around. So that's kind of how we came up with JSONair, just like make it simple. So everything that you do is just an API call away. So there's no files that are moving around. Even if your system requires a YAML file or something like that, we don't really care about that. It's read only, it's unidirectional, meaning We don't try to make it the end-all be-all of all configuration management. This is a way for your software to talk to a centralized point that's cloud agnostic and get its configurations from it. We don't want it to be able to write configurations to it. We want it to be a unidirectional. The writing, our opinion, for these type of applications should be on the other side and not accessible from the client side. And besides, we don't really need it, at least at this point in time. The format's agnostic. We don't really care if it's a YAML file, if it's JSON blob, if it's an INI file, if it's some crazy format that you developed in 1983. Doesn't really matter to us. We decided to write it in Go. I've moved a lot. As the previous license did a lot of C programming. Moved over to Go. I find for things like, especially when you're doing cloud native stuff, Go is a really, really good language to use. It's static, it's safe, has built-in garbage collection. It's safer than C, but that's a low bar. It can run on, trust me, I punched myself in the face enough to know how bad C can be. It runs in, as I said, it runs in containers. You can do it in a VM, run in bare metal. You can set it up for support for an HA configuration. You could do like AWS and have multiple containers behind a load balancer. So as you're upgrading the services, you can make all this HA fairly easy. And as I said, it's all MIT and open source. So our core philosophy, keep it simple, stupid. I'm always like that. It's the way most things should be. So simple beats clever. Well, we want this to do one thing. We don't care about bells and whistles. It doesn't need to solve all of the world's problems. It needs to just constantly work. It needs to be read-only by design. These are the requirements for us internally. We don't want validation. Some of these configuration engines, when you put it in, they do nice things. They'll say, like, hey, that YAML isn't valid, or that JSON is not valid, or this INI is not valid, or this XML is not, like, we don't want to validate every dumb thing in the world. So what we do is we just say we're agnostic. That means from your standpoint, when you're making the API call, you have to validate it, because we're just taking as arbitrary data and pushing it over to you. So that if you're loading in a config, you have to say, are these environment variables set up the way that they need to be or whatnot? Has very minimal external dependencies. We're doing mostly MariaDB type of backend, MySQL, but this is easily work in Aurora DB or something like that if you want a more cloud native type of cloud situation or backend storage. We also try to run as least privs as possible. So if you're running on port, you want it to run on port 443, we start up, bind to the port, immediately drop the root privileges, and then run as a local user so that we're not just sitting there with all those privileges. Obviously, if you're running on a port over 1024, then you don't need root privileges anyway. So to give you kind of an idea, so there's a server aspect, and that holds all the configurations and everything in there. And then in this particular case, we have a JSONair agent. And this is kind of an agent that just watches your config files and can modify them and then push them out of the way and restart services. So this is like a very basic agent. The real reason the agent was made is to give you an idea about how the whole system works, about how API calls work to JSONair. So what happens is when the agent starts up, it takes a snapshot of your configuration.yaml. It actually hashes it real quick and then stores that in memory. Then it can go out to JSONair and it'll say, hey, JSONair, let me authenticate, prove who I am, whatnot. Then once it connects up, it says, what configuration do you have? Then it hashes that as well. And it takes the two, basically says, are these two the same? Because if they're the same, I don't need to do anything, and then I can go to sleep for a certain amount of time. However, if there's any updates to that, then what we do is it'll swap it out. I'll make a backup of your current configuration. It can also keep an X number of backups, so in case you want to roll it back or whatnot, you can, but it'll push out that config to that service. And then at that point, it can also restart the process as well. So that's kind of what I was talking to about here. So, well, I think it goes into reload later. But from a security model standpoint, what we do is, and this is fairly standard for most stuff nowadays, when the agent starts up or your software starts up, you have a personal access token, a PAT, which is stored in an environment variable only in JSONair, the server side, the agent side. And whenever it connects up, it trades the PAT for a JSON web token, right? And that's a temporary token that it's going to use for the rest of its authentication for that time. The idea is that if the JSON web token gets snarfed, that it'll only be valid for a short amount of time, right? So every request after that to get a configuration has to use that JWT. I think by default, I think we set the token to be an hour long, but it's configurable. You can set it to whatever you want. So the idea is that the PAT only crosses the wire only whenever it needs to, for instance, like at startup or whatnot. We don't store the PATs, the personal access tokens, just plain text into the database. We SHA it, but then we use we actually use the HMAC SHA 256, but then we use a secret to SHA that. So the idea here is that if somebody breaks in and they steal your database, that those tokens are not available to them. And here goes what I mean. So if you use just a regular SHA 256 and we take two strings and they're the same and we SHA them, they'll be the exact same string. What the HMAC and all that stuff does is makes it so that every time, even though I'm encrypting or doing the same string, it'll be different every time. So that if the attacker gets it, they can't look through and say like, oh, look, they have 100 SHAs that are the exact same. Those PATs are all the same, so to speak. They won't know. It keeps them in the dark about that. Because remember, the PAT, we only need to have one direction. We don't need to decrypt stuff. We just need to validate if it's actually the agent talking to us. The configuration data is stored at rest using AES 256. And it's also using a nuance as well. So whenever we encrypt the configuration data, you can have the exact same configuration data and then re-encrypt it, and they will never match anything else. So the idea there is like somebody steals it. Once again, they don't have the PAT and they don't have the configuration data as well. So, so again, yeah, identical data, different ciphertext. That's the idea there. We also add in some rate limiting. Also, this stuff is all configurable. The rate limiting, just make sure that nobody's, for instance, trying to brute force your PAT. Be kind of waste of time anyways. But you know, people do strange things. And then, as I said, we drop the priv as soon as possibly can. So to give kind of the agent's point of view, as I said, the agent's running on the machine. For instance, it could be monitoring a web server config. It could be monitoring Suricata, which is like a packet inspection config. It could be running, and it's just monitoring this config. It takes very little memory because with Golang, it's a compiled language. It has a pretty good footprint for that kind of stuff. So the workflow on the client side is that whenever it fires up, it authenticates to a PAT, gets a JWT, and fetches the configuration. Notice I put some stars here next to the second thing. You'll notice the configuration has a type and a name. The type can be web services. The name might be main office. The type could be web services and then our backup server. Type, it kind of acts as like a directory / config file so that you can say, these are all my IDS engine configs. These are all my web server configs so that you can keep things split up in that kind of logical order so that you can also have like one type, or excuse me, multiple types with the same name of file within each name of the configuration. So that's what I mean by the configuration type and name. So whenever it starts up, it computes the hash of the config. It compares the hash. It grabs the hash from JSONair. Says, do I have anything to do? If it does not, it goes to sleep. If it does have something to do, then it says, okay, let's back up the current config. And then it has a purge function in it. So it'll only back up X number of configs so you don't wake up like a year later and do LS and you have 47,000 stupid config files out there. I've done crap like that. So it'll back it up, but keep only a certain amount. And then it reloads the process. And the reload option can be however your software reloads. But that does make it mean that if your process is running as a web server, it likely needs the same user permissions or levels for it to be able to restart that process, right? We don't really want these processes running as root anyways. So for instance, if your web server, if you're under Debian, it's like www.data or something like that, you'll need JSONair running as that same user. So that whenever he says, hey, I need to restart the web server, he has appropriate privileges to signal like a sig hup or restart the services or whatnot. That is the idea there. We also made it so, and we do the same thing in our software as well, that the software, it remains resilient. And here goes what I mean. The agent needs to keep running no matter what. So if it goes to talk to JSONair, and get a configuration, and JSONair is down, the agent can't stop. it has to just keep trying over and over again. The idea is if you have 100 servers out in the field and then your configuration backend is blocked, some sort of outage, you don't want to have to go to 1,500 servers and restart JSONair. It needs to remain in memory, so no matter what. So no matter if it's getting a 500 error or whatnot, it should just sit out there and keep retrying until things come back to normal, and then it can start doing its process over again. Last thing we want this service to do is just stop. And then once the service comes back online, everything will continue as normal. Even if the JWT is timed out, it'll just send the pat and get a new JSON web token and continue from there. So the agent must never die during that. Another reason is because the agent will keep working with the last known good config. It's not going to restart your software. It's just going to sit out there and just continue trying and trying and trying. When it comes back up, you'll probably have not even made a configuration change anyway, but it just keeps running with, your software keeps running with the last known good config at all times, right? And then everything's timestamped from the pruning standpoint so that whenever JSONair, the agent side of things, says, hey, I do have a new file, it'll back it up, give it a timestamp so that you know about whenever this particular thing took place, and if you need to roll it back or whatnot. As I said, dependencies are pretty light. So MySQL, Postgres, not Postgres. If you want to add Postgres, please, by all means. But right now we're just doing mostly MySQL because that's what we run a lot on our backend. Actually, a lot more Aurora DB, which has basically MySQL type of backend. Semi-modern Golang toolchain. There's no shared libraries. There's nothing in particular that you have to really worry about. It compiles into, just like all Go stuff, it compiles into a static binary, meaning like in C and stuff like that, when you compile and usually link, unless you're telling it to do static, it compiles, but it relies on lots of shared libraries of the system. Go makes everything compiled and just everything gets built into the one package, meaning you can copy one file and put it on like the agent, one file, put it on the system, and you go. You don't have to copy that and install 47 different libraries to deal with all these other different things. There are a few key packages that it needs. It uses Golang Gen for the HTTP routing, Golang JWT, a lot of internal stuff for it to use. So like, go.env, so it can read .env files at startup or read environment variables. The idea here is like we want it to be malleable enough that you could run it on a pure out Linux system, or you could run it in Debian, or you could run it in a Lambda function in a cloud container, or ECS in a cloud container in AWS, so that it can be moved around pretty statically without having to have a whole ton of changes. So it's it's intentionally minimal. Database setup, I won't get too much of this, but it's your typical kind of stuff. We end up really only having a couple of tables that we really worry about. The keys, that's where like your pat lives and stuff like that. The JWT stuff, that lives in memory, so we don't even have to store any of that. But the pat, and that's where all the encryption happens there. And then you have your configuration data. We make the config data size. It gets buffered out a little bit because the config data actually gets stored encrypted as base 64. So it gets padded out by like 20 or 30%, but we give it about 16 meg. If your configs are bigger than 16 meg, you should probably re-examine what you're doing in the first place. But if you want to, easy enough to add and support. If you want to make it, I don't know, a gig of text, that'd be terrible. But you could do that if you wanted to. This is on the server side. So when the server starts up, there's not a whole lot that you have to worry about. It has to know where the SQL database is, obviously, and how to log into it and stuff like that. Then you can set up your HTTP service, which is going to be from your API endpoint. And you can tell it to use TLS, and then you can set up your certs and keys. In certain situations, for instance, like if you're using an application load balancer in AWS and your TLS is being served in front of the load balancer, it may only be to 80 on your back end. It just chooses how you want to do it. So you have the option of using it encrypted, not encrypted, stuff like that. But the key stuff that really gets into, that's important, but is this stuff. And this is the way I generate my random keys. So the JWT token secret. This stuff stays on the JSONair server. This stuff must not leak. It has to be there. It cannot be, you don't need to put it anywhere else in the world, because the secret is how it generates, after you use your pat, how it generates the JSON web token for future usage. And then the expire, and then the HMAC secret is for your PAT, so that it knows how to do store using a secret key only available through the JSONair server, how to store those PATs so that they're not recoverable in case your database gets compromised or something like that. And then the config encryption secret is for the decrypting the configurations out of the configuration database. So they come, they say, hey, this is me, here's my JWT, I want this configuration. From the back end, it decrypts it, hands it back over to you, but in the database, it just remains encrypted all the time. So these keys are the things that you really don't want to go anywhere, right? And then you can set it who you want it to run as. So to start it up, there's a bunch of different ways to start it up. Depends on what type of environment that you're in. If you're running in a container, you might run it a certain way. If you run it in ECS, you might run it another way. But for the most part, you can just run it directly. If you're on a Linux box and just want to test it out, you can just run JSONair, which just reads from an environment variable in the same directory as it. However, you can run it through, a lot of times whenever I'm testing, I'll use just environment variables because I don't want to have to keep going in and I just find it easier for me when I'm testing. But environment variables, so you'll read either or. So you can read either your environment variables out of the env file, or it'll read them out of your environment variables in memory on the system. Or you can do it out of systemd service, obviously, if you're doing it on a Linux side of things. But if you're doing it in like a cloud environment, there's multiple ways that you may want to do it. So we're trying to make it as friendly to that as possible. Once it first starts up, it gives you a banner, tells you all the information, also tell you that it's encrypted, also tell you if it needed to drop privileges or not, so that you know that it's not running as a root level user. As I said earlier, all the data is stored in a encrypted format. So we have a little tool that we give with the actual program, which is just called JSONair encrypt. So basically what you're doing, like this is my configuration file. This could be a web server file, whatever that it is. So we're base encoding it, the file itself, or piping it. Remember that one of the secrets that we had, remember this is server side, that secret, and then we tell JSONair to run, and it dumps out a new piece of JSON for it, or not JSON, base 64. And then you take that base 64 and you can just copy it into your database, and then you're good to go. So the encryption key has to be the one that you're using in your configuration store, so to speak. Obviously, there's sometimes you want to go the reverse direction. So there's a -d flag, which lets you decrypt it. For key rotations, what you could do is you could automate it by saying, go through everything, decrypt it with this key, make a new key, now re-encrypt it, now push it into the database if you so wanted to. But hopefully you don't need to do a ton of that. So this is still on the server side of things. It's just a really simple API. There's not really a whole lot to it, and that's by design. So the base URL is your web service, www.jasonair.com/API v1 JSONair, and then you have these 4 different requests. Obviously, the first one is for authentication. And then the rest you don't get to have access to until you pass this particular one. So the idea here is like, if I want to get a config, that's the way I get my config. If I need, you can also pass debug levels. So where we found this useful is like, imagine I have some systems out there and I want to run them in a slightly different debug level. I can just do JSONair, tell the program, run at this particular debug level, and then it'll pass a token over to your service and then say, run at this particular debug level. Then when you get tired of it, you say, okay, stop. So if you build internally to your program, not only to grab the configurations, you can also tell it, hey, also grab any kind of debug information. The idea is like, I don't want to have to stop and restart containers, services, programs just to change the debug level. I should be able to just change it on the fly. Most Linux programs, you could usually change it and do a kill-1, do a sig hup, and then it'll restart and reload and it never leaves memory. But in container world, for some reason, whenever I watch a lot of people do it, they actually go, oh, let's change this 1 or 2 little things, and they shut down the container, redeploy it, and all this crap. And it seems like a waste of time. So the idea is that you can use that to alter debug levels in your production level. Like if you're having a problem, go back and say, hey, debug this particular option. And then the containers will just automatically inherit on their next pass. Say, oh, okay, so set the debug, then you can set it back and then set it back down so that you're not spamming logs. And reload can just be simply for, hey, I just want you to reload that software for me. Just restart it for me. But here's like what a basic authentication thing looks like. You'll see it's kind of pretty simple. It's just this is like just a simple curl request. We have our bearer token, the JWT, and we just call it, and then we tell it the type. I want the, as I said, think of the type. That's kind of like the directory, and then the name is actually the file that you want. The name, you'll see, I even call it suricata.yaml. It doesn't have to be that. It's your system. You can call it whatever you want. It doesn't have to be .yaml. JSONair isn't going to be like, this isn't a valid YAML file. It doesn't care. So whenever you do that, it'll dump out in one of two ways. It can either dump out the configuration of base64 format, which you can use to decode. I'd say you do that if you have something in your config file that has like Unicode or something in it. Otherwise, you can just say dump it out as plain text and just have your server use it that way as well. So it's pretty straightforward. We have pretty good documentation on it, and a lot of the code, I was actually going to put some of the code on the slide, but if you go, this is the general documentation on how the API works. The rest of it is just like, here goes how you would use it in these environments. Like, so in Golang, it's probably a function that's no more than 15, 20 lines. Python, I think it's even less. And then in Bash shell script, you can do it in probably 5 to 7 lines. So it doesn't take a whole lot for you to do that kind of stuff. So, yes. So if you guys have an opportunity, ladies and gentlemen, please just check it out. It's a pretty simple type of program, but we found it to be pretty resilient and works really well for us across our configurations. We're using it for everything from configuring software that we have. So like on our backend, on our identity platform, we have a bunch of ECS instances that are running behind an application load balancer. And we use JSONair to make sure they have their configs all up to date all the time. So if we want to do a change, we don't have to stop production, we don't have to do anything, we don't have to roll anything. We can just push it out. We use it for, we've been getting really big into A2A agentic flows. A2A is like a protocol that Google came out with. Agentic flows of that, so that like I'm watching people, this was driving me crazy, where people would like start their agent and be like, oh, I need to add a new skill to my agent, Control C, add the new skill, restart it. Like, no, just pull it from somewhere so that we don't have to restart agentic agents and stuff like that. You can say, oh, I need to add something to the skill, and go in and add it in and just push it in and go, okay, and then all the agents just reload automatically. So we don't have to have downtime on that as well. So, but if you do use it, I appreciate hearing about how you're using it and whatnot. And you can use it in your projects, as I said, for that. And as I said, we are using it in production. So if you have any issues or want to submit PRs, please do. And that's pretty much it, but I would gladly take questions. And that was kind of a weird one. Yes?
So I had two. First one, the primary way the downstream device or downstream service gets a new configuration is polling, and that's a polling that you would set on that downstream system to
yes.
check the API.
Yep. You could just have it. It's basically, yeah, and so it makes it so that in some services, if we have really less important services, we pull once an hour kind of thing. But if I have a service that I'm really kind of worried about, I might pull every few minutes or something like that.
The other question I was about ingesting your, like maybe let's see if a config you want to change. Right now, the only way to update the config is via interacting with SQL directly?
It's using the JSONair encrypt and interacting directly. We have built into our software, we have management platforms. I would like to come up with something that was like an open source sort of interface that allowed you to interface, because it is really cumbersome, just to be straightforward. Yeah. Like you're like, oh, you know what? I'm going to make a modification to that config. I want to change the whatever in it. And then you go in and you're like, oh, okay, crap. Okay, modify the config, base64, encrypt it, paste it into here. And then you're like, crap, it was a typo. I got to do it all over again. But with the interface that we use for internal software, it's like a regular editor.
Presumably you would be updating your configs in a pragmatic manner. So it's not like you editing in Notepad. I know the way I do it in my systems, I use Git. Repos.
Right.
I just push the new config up to my internal Git server.
It's yes, and yeah. Then it do you have like a CI/CD pipeline that pushes it out or something?
Absolutely. I absolutely don't pull every 5 minutes.
Okay.
To an internal mirror server that has the Git repo, but now just without authentication.
I gotcha.
On a different IP address that's firewalled off.
Okay. No, right on.
Get into whatever I have.
Well, this is the way that we found.
I like this a lot better.
Yeah, we found this one worked pretty good.
I just feel like the difficulty I see is in my process
You-
is very manual to update a config
You
file.
actually are not wrong. What I thought about doing, like, so I'm a big Vim user, is just doing a wrapper around it of some type, just like whenever I was first doing it. But then I talked to one of our UI guys, and he was like, I can do this in like a few hours. Why not just write it? So he just wrote it, and so now, like, I just go into a screen, it has a JSON editor, I make the modification. Then on the back end, again, he takes care of the re-encrypting, putting into the database, stuff like that. So I'm hoping that we can get to a point where we're not just doing it in our software, that we can have like a back end, maybe something that's really static. Like I like Go a lot because like there's not a server for, what's that? It's reusable. Well, plus, like, if I did in PHP, now I'm like, okay, now I have to have all these PHP modules load in Apache and all this garbage, and I don't want to do that either. So maybe like a simple web front end that allows you to interact with it easier, But that might be
Just
what
to
it
see
is.
which ones exist. I can imagine that being another thing. Like, what's the name of the config that I need to? I'm working on my server.
Right.
What application was it? Was it?
Right. Well, I think you could have it like list, like,
Client? Yeah,
here are your types, and and then you select a type, and it says here are your configs, and you select the config, and then it pulls up a YAML INI file, whatever that it is, or whatnot. Do you have another question? Yeah. Yes, sir.
Thank you for the presentation.
Thank you.
Have you ever come across a situation where you need to distribute from your main server to other servers so that they can pass it out to the client?
Like from like the server to a client to other clients?
Basically, I mean, for example, if you had your main configuration, and you wanted to pass it down to a student server and a teacher server, and then have them distribute it. Do you ever have that situation, or do you just like directly
For
to-
our use, we haven't really had that situation. I mean, I could see simple ways that you might be able to do that, but no, we haven't had that. No, sorry, yeah, just haven't had it.
No, it's just a.
Well, I mean, there's all kinds of weird stuff you can do. As I said, like, so the config data is pretty arbitrary, right? Like, it doesn't really care. I put a zip file in there. What difference does it make? It doesn't validate it. It doesn't do anything. I'm not advocating for that. That's not really what it's built for. But you might be able to do some like sneaky stuff to move stuff around.
How you can do updates on your server? You just have it in your binary.
Right.
And then,
Copy this DLL over
right,
here.
right.
That's not dangerous at all. Any other questions? Yes.
So I'm studying for Security Plus,
Okay.
and I'm still very new. So question,
Yeah.
you said you encrypt with SHA, and then you add tokenization on top of it. Is that the same as salting?
Kind of similar to salting. So when you look at the traditional days of like the old school, like etc shadow file and stuff like that, or etc password, that was the way that they did it. They did salting so that if you had two users with the same password, it wouldn't have the same values in that particular field, right? I mean, it's very similar to that in that in that whenever you encrypt two pieces of data that are the same, it can create a nuance so that when it encrypts it, they won't appear the same, right? Because like traditionally, like in old school like DES days, like when you encrypted something and you used a key, and then you encrypted another file that was the exact same, they would just have the exact same kind of layout because there wouldn't be anything, to prevent that from happening. It was just math. But it's similar to salting, I would say. I mean, what do you think, Travis? Is it similar enough to salting? Would you say?
What was the hash, or are we talking about hashing here?
No, we're talking about on the encryption side of things. So for instance, like you could even talk about with PAT, how we're using SHA, but with HMAC and SHA-256, so that each SHA that's generated isn't the same every single time. I would say it's very similar to salting. Yeah.
I was trying to wrap my head around it. So
No. You actually got it. I mean, I think I'm sure there would be a math nerd out there that'd be like, no, it's completely different. But to our general things, it's roughly the same.
Yeah, it's like he was saying, the whole point of the salt is to make it so, like, for example, say that we were encrypting something that was like L file repeatedly. The header structure is the same on almost every single one of those, and the encryption is usually like 16 or 32 bytes of data. Those blocks would be completely identical. So it's one of those things that, like, there were some attacks that you could do against like zip files. If you actually had a clear text of one of the files in there, you can actually decrypt it a lot easier because of the fact that you knew the structure. The other thing is with salts is that gets used a lot in like password hashing, and the goal there is to make it so, like, have you heard of rainbow tables?
Yeah.
Okay. I cannot generate a rainbow table that's gonna have every possible password in, SHA-256 with every single possible salt. That just isn't.
Right, it would be
very realistic.
petabytes and years of generating, right, right. And also, there is also another nuance too, because like on those type of systems, they're not looking to decrypt anything. Usually like it's a salt and then it's a one-way encryption type of method. Same thing they're doing with the PAT.
Yeah.
So-
Usually the salt's just stored in plain text next to.
Right next to the thing. But the idea is that whenever, like with the SHA stuff, we're doing encryption and comparing. We're not decrypting. Like we never get back the value of the PAT. So like if somebody came to me and said, "Hey, I deleted the PAT off my system. Can you go into the database and get it?" I go, "No, I can't. Like it's a one-way function. So you have to encrypt it, or it has to be encrypted and compared to the value. And if the values are equal to each other, then we know it's true."
Are you comparing the hashes? How are you comparing?
So if you think of like, okay, have you ever used like SHA-1 or SHA-256 or any of those?
I'm day 2.
Okay, okay. So SHA-1, we'll just keep it like on the easy side.
And I
SHA,
can do after if you want to stay more focused on JSONs.
I don't mind. Do you guys mind? No. I don't think anybody minds. The SHA, if you use like SHA-1, okay, and you have a file, and the file says, this is a test, right? And you say, I wanted the SHA hash of this file. It'll give you a string of hexadecimal. It'll be kind of like 32 characters long, something like that. So that'll be the SHA-1. So if you have another file that says this is a test, and you generate a hash, those two files will have the exact same SHA hash, right? But now think of those as like passwords in a password file, right? So when the program goes to find out if this is a test was like the password, it stores just the SHA value. So you type in this is a test, it SHAs it and then compares it to what's in the database. Do you see what I mean?
Okay.
And then it says, oh, those SHAs match, return that back. That's basically what's happening with the PAT, but we're doing salting on top of that. So if somebody gets those hashes, they can't, it makes it more difficult to brute force those because to Travis's point.
Hash of like a config file?
The PAT is just a random hash.
Oh,
Yeah, the private access token or personal access token. So anyways, that's a good question. Any other questions? Awesome.
What's your favorite 16-digit prime number?
That's a little too personal.
Yeah.
No.
Say it slowly. Say it slowly.
Jack, you should have said 3.141.
Yeah, I wasn't specific that it had to be an insert.
Yeah.
That's why
You
I
can get
said
away with
we
a float.
could-
Yeah, I should have said. Was it a float or are we talking? Okay, yeah. Oh, well.
And then you can put it to E, and then we can just.
Yeah, we can just.
Or make it a negative.
All right, thank
So,
you.
yeah, thanks. Thank you, everybody.